Hi, this is Tampa Tech, and learn something new from PC, TVs, and gaming too. Let's get it started.
So I'm going to show you guys how to use a meter. This is the Fluke 12 multimeter, or DVM, digital voltmeter. Okay, I use the Fluke 12 multimeter. I've been using it for 10 years. Works awesome. It was about like $100, and it reads capacitor, that's the symbol for capacitor, microfarads, up to 10,000 microfarads. I believe this does. Anytime you read a capacitor, you have to read it out of circuit, and you have to discharge the capacitor, or else it might mess up your meter. If your meter gets messed up, you have to send it off to Radio Shack to get it fixed, and they fix it up. Sometimes the fuse inside the meter goes. You can replace the fuse yourself, but if it's beyond that, then of course you have to send it out at Radio Shack and they'll fix it. I think it cost me $50, but it's a $100 meter. This is a symbol for ohms, which is a resistor. This is a symbol when you put it in this mode right here. That's beep mode, but it's actually diode mode. That's a symbol for diodes. The line is the negative. See that line going up and down? The negative is called the cathode, and the positive is called the anode. At least that's what they told me in school. Anyhow, now if you move it over to right here, that's the volt symbol for DC. So a straight line is a symbol for the DC, direct current. Now if you hit this button right here, you get a wavy line. Well, that's a symbol for AC, and it's wavy because it's alternating current, AC. It alternates positive, negative, negative, positive every 60 hertz, I believe. 60 times a second. It alternates positive, negative, negative, positive. So anyhow, moving forward, and this is off. I don't know. I figured I'll show you that. And let's go diode mode. Diode mode, you could read transistors and bridge rectifiers and diodes. Okay. Capacitors, you could read capacitors. Oh, that's the microfarads. Okay. And then hit this button. Every time you hit it, it cycles, by the way. So this is, you read resistors right here. The best way to read components and parts on this power supply is by the most accurate way is taking it out of circuit. So what I would do is basically, if you have the red LED light on the screen, on the front panel of your TV screen, most likely you got power going to the TV. Okay, if you don't have that red LED light, I would probably check the fuse. Alright, and that's the fuse right there. How I know it's the fuse? Because it says fuse. It's F1. F stands for fuse. 1 is the location number on the board. And between there, it says CN1. Now this means connection 1. See how it says CN4? That's connection 4. See how it says CY3? Well, this is a capacitor. Usually these don't go bad. You could kind of tell it when they go bad. There'd be like a crack, a slight thin hairline crack in it. But with the fuse, this is how you test it. You flip the board over. You put this in diode mode or beep mode. Okay. And then if it sounds like this, well, that's a closed circuit. If it sounds like that, that's an open line circuit. So that's why it says OL. OL is open line, open switch. So open switch, closed switch. Okay. Now that you know that, let's check the fuse. Alright, so the fuse is good. It's closed. Basically, a fuse is a thin hairline wire running across from one pin to another. That's the only thing a fuse is, basically. Alright, and a circuit, basically, a circuit has to be complete. It has to be a negative and positive, and it has to have a circle. That's why it's called circle. And electrons move throughout the circuit. Okay, but it has to be, you have to have the positive, or basically the opposites attract. Negative and positive, they attract each other. So that's how the circuitry moves throughout the electrons move throughout the circuit. If that makes any sense. I probably just confused you even more. Anyhow, moving forward. I usually check anything on a heatsink. I would normally check just because it gets hot, and that's why there's a heatsink. These metal plates right here, they anticipate heat away from the components. And the components are the TV parts. Alright, so that's why there's heat sinks, because they work hard. So I would normally check anything on a heat sink. They typically, not typically, but usually go bad. Alright, so I'm going to show you what a diode is. Basically a junction of, a bridge rectifier is basically a junction of diodes. And its job is to change AC to DC. So this TV doesn't work on AC, alternating current. It has to work on DC, direct current. Alright, or else it's not going to work right. So that's this job, to change AC to DC current in the circuit. So let's flip it over, and you get the four legs of the diode, bridge rectifier. What do I keep on calling it? Bridge rectifier. Okay, so you want to read it like this. I want to show you the meter. So you want to put it in diode mode. That's the symbol for diode mode. So let's put the negative lead, which is the black lead, on the cathode of the bridge rectifier, and then the positive. And then you get 0.5, which is perfect. Okay, anywhere between 0.4 to 0.6, that's the range. 0.5 is perfect. And then basically what it does is, a diode basically its job is to allow voltage in one way but not the other. So when you reverse the leads, you'll get an open line. So 0.5 volts one way, and then open line. And then do the same thing over here. Negative, positive. 0.5 volts, and then reverse the leads, open line, and then do it for the middle. Or where's it? This way. I'm sorry, I forgot how to do that for a second. 0.5, and then you reverse it, open line, and then I think it's this one. 0.5, reverse. And that's good. So boom, that's it. You do that. Now I'm going to show you the transistors. Transistor, you can read in diode mode also. So let's go ahead and read that. Transistor typically has 3 legs. Alright, bridge rectifier has 4 legs. Here's more transistors right here. Capacitors, you have to read out of circuit, so you have to unsolder them and pull them out. And if you want to unsolder them, you would have to use a solder gun and solder plunger or solder sucker. Alright, so you can get a in-circuit capacitor meter, but that's $100 all by itself. Another way to unsolder, you can use a desoldering wire. So that's another way to take capacitors out of circuit. Typically, if the capacitor is bulged or swollen looking, you would replace it. But some bad capacitors may look good, so you have to take those out of circuit. I just get the cap kit. I buy the cap kit on Amazon, or shopjimmy.com or something, and I just deal with the cap kit. Or if there's too many parts to replace in the power supply, I just buy the power supply for like $50 and save me that time and hassle. Even though the only way to really learn is to read the schematic and replacing part by part, component level. So anyhow, let's go ahead and check out the transistors. So here's the transistors right here. Let's flip over the board, and when you look at it, you'll notice there's burn marks right here. Well, this is a bad power supply. So these are just open line because they're just popped. See? Even though they look like they're running across, they're not running across at all because internally they popped. So they look like they're actually closed, but it's actually blown open. So let me read the transistor legs. And on the transistors, there's part number. And you just Google it. That's a reference number. That's how you know what part to replace. All right. So let me go ahead and read those. Let me see. To take those off, you have to take out the screw and then pull them out with the desoldering wire. And then you can usually get the grease. See how there's that white stuff? Well, that's so the heat will transfer onto the heatsink. So you need to put that back on. Make sure you have to buy that grease. They sell it at Radio Shack. So when you test this one, I'll show you. Put it in diode mode once again. So there's 3 legs, 1, 2, 3, and it says 0.3. And then just do it over here, open line. And let's reverse the lead, open line. Open line. And then touch it over here, 0.3. Reverse the leads. Uh-oh, 0.3. See, it's not reading right. So that transistor is bad. The best way to read it though is out of circuit. That's how you know for sure. So I would definitely take that one out and retest it. But because his twin brother right next to him reads 0.5 and reverse it and it reads open line, kind of tells me this one is bad, this transistor is bad, and this one is good. Because yep, see, it's reading good. 0.4 is on the borderline, but it's good. So this one, and here's the other transistor right here. 0.5, open line, 0.4, open line. That would change out that transistor, this transistor right here. And this is the board number, by the way. If you could just replace the whole entire power supply board. And make sure you have the 0.1, 0.8, and it'll say 2008. That's like what year it was made. So you want to make sure you get the same board. Some boards you get a 2009 board, it'll still work, but make sure all the parts and all the connections are the same. All right, and you could talk to the tech representative, and they'll let you know if it'll work on certain TVs. Power supplies aren't like this, even though it's a Insignia power supply. Other power supplies and other TVs could work in Insignia TV. They interchangeable. Like you'll see a Samsung power supply and a Philips TV, which is kind of weird. So anyhow, here's a diode right here. So the stripe on the diode is the negative, and right here is the positive, which is called anode, and this is the negative part is the cathode. So you read that in diode mode, and it reads 0.1, so it's kind of like doesn't read that good. But I took it out of circuit. I snipped it, so I wanted to read it out of circuit. By snipping one of the legs, that's how you read it out of circuit. But it doesn't seem like it reads that good. I had to freaking get this. I want to show you guys, but it's giving me a hard time apparently. Alright, so 0.1, that's not really that good. So Jesus, I'm getting all tangled up here. Sorry, guys. Oh, brother. See, this is what happens. You got these wires, they go freaking tangled up like Christmas lights. I wish they had like freaking wire, these stupid lead wires that you can like pull in and out, you know, retractable. Still waiting on that. 0.1, and then do the same thing for this one. And this is 0.1. But I would read these out of circuit, and because they're only like maybe 50 cents or $1, I would replace them. Let me see what else. Oh, the capacitors. Capacitors you would read out of circuit. So you would have to unsolder the capacitor to read it out of circuit. Normally, like the capacitors I would look for, or pretty much like the 1000 microfarad capacitors. I often replace the 470. Not typically the small ones. But the small ones do go bad, don't get me wrong, but not as common as these size, the medium sized ones. It's more of a common, you know, fix for me, in my case, my experience. So basically, you just unsolder the capacitor. You can't read it in circuit. Now here's a capacitor I got right here, and this is 3,300 microfarads, 10 volt. And so I'm going to show you how to read that. And you would read in capacitor. So move that switch to the right, and then hit that button for capacitor right there. And then the stripe is the negative, so you want to put the negative lead right there, and then the positive lead right there, and you should get right about there. You don't want to touch the lead. You want to make sure you don't touch the lead with at least one hand. You get a better accurate reading. Discharge, come on, discharge, there you go. So that's a good reading. So even though it says 3,300 microfarads, it's reading 4,000, it's still good. So here's a capacitor that is bulged or blown. Alright, so let me show you that one, how to read that one. So you put that lead right there, negative lead on the stripe side, positive lead on the other side, and it reads 110, 103 microfarads. And if you look on it, it says 1,000 microfarads, 10 volt. Alright, so this one's definitely bad. So it's reading way below. I mean, if it read 950, that would be okay. But because it's reading 100, and it's 1,000 microfarads, that's way bad. And you could tell because it's also swollen or bulged on top. So I would normally just replace it because it physically looks bad. Okay, now to test a resistor, like this one right here, you read it left and right, and so the color band, let's say gold or silver right here, you would read it left to right, starting from the green, and what is that, blue and brown. So green on the color code chart on my tampatech.blogspot.com, there's a color code chart. I have to zoom in on it, but it's there. Green, I believe, is 5, if I remember correctly, and in blue is 6. So it's going to be 5, 6, and brown is the multiplier of how many zeros. So brown is actually a 1. So it's 5, 6, 0. 560. Alright, and that's the tolerance, the gold band. So let's go ahead and read that and see if it's correct. You should read about like 10 to 15% in value. So let's put that right here so you guys can see. And there's no polarity, there's no negative and positive on a resistor. Oh, and put it in ohm mode. That's what it looks like, a horseshoe, but it's ohms resistor. And 5, when it says K, K means 1,000. So when it says 0.545 K ohms, it's really 545 ohms. So if it was 1.1 K ohm, it'd be 1,100. So this is a little low, but it's good. And also, I want to note that if you see any loose solder joints or loose pins, and you can wiggle it, go ahead and solder that. That will give you a better connection. So sometimes it's cold solder joints. Cold solder joints is basically a loose solder pin or solder joint. You want to make sure those are soldered up very well, and sometimes it could fix your problem. Now also, to recap, I just want to let you know, you can smell what's wrong sometimes, and there's a smell on the power supply or the TV board. There's also physical, so you can see. So use all your senses. You know, you smell, your sight. You can see something that's bulged, or a capacitor that's swollen, or something that's burnt. You see a burnt coil, or a cracked capacitor right here. You know, of course, replace those. Anything that you see damage, you would know. Any like burnt marks, basically. And anything on a heat sink, I would test. And LCD and plasmas are known for bulged capacitors, but also, you know, chips do go bad, like transistors and stuff like that. They do go bad, stuff on heat sinks. So you want to check out for, watch out for that stuff too as well. Thanks guys. Post, comment, subscribe to Tampa Tech, and like this video if it helped you and you learned something new.